Welcome to the Math Record. Today I'll be covering the second part of the ICTM Regional 2018 Division AA Junior Senior 8%, which I will be covering questions 14, 15, and 18. Okay, let's begin with 14. The area of the region that is inside the graph R equals 4 sine theta, but outside the graph R equals 2 can be expressed as k pi plus w squared p over q, and then find the sum of the coefficients. So let's just draw this and see how this looks because if they're using theta and r, we're basically using the polar plane. And from the polar plane, how would 4 sine of theta look? Well, 4 sine of theta is just a circle up here. And the radius basically tells us it's gonna be 2. And the reason is because it's because it's kind of square root of the 4. So what we have is we have a circle, and this is radius 2. So we know this is radius 2, and it's on this in the polar coordinates. So how it kind of looks is looks like this. It's not really, I can't really draw that well, but basically it'll be like radius 1, radius 2, radius 3, radius 4, and then you're going by theta. So that's basically how you graph in polar coordinates. If you don't know what it is, you kind of want to search it up to see how you solve it. And then we have a graph of radius 2. So since this is 2, we have a circle of radius 2 from the origin. So something like this. Okay, so I'm just gonna make another circle because I suck at drawing. A little bit bigger. They're about the same. And something like that, basically. So basically what they're asking now is find the area of the region that's inside this graph, but it's outside this graph. So we want to find this area right here. So first we need to find this area. And what I could do is that I kind of could split this up. So connect the points of intersection. So from here to here. And then I could basically make a, let's say, line right here, line here. And what does this tell us? Well, what I notice basically from here to here is that if this is the radius of our circle, and this is also a radius of our circle, because they're both radius 2, because that's what r equals 2 is, then we could connect a point also right here. This triangle right here is equilateral because this is radius 2 because this triangle. This is radius 2 because that's this triangle, and both these share the same radius, which is also 2. So that's equilateral. So what that tells us that this triangle is 60 degrees right here. So that means this is 30 because this is a right triangle. So that tells us that if this is radius 2, that means this is using a 30, 60, 90 triangle. This is square root 3. And kind of hard to see. This is square root 3, and this is length 1. So the area of this triangle is square root 3 times 1 divided by 2, which is just square root 3 over 2, which is the area of this triangle. But remember, if we kind of draw here and here, we have 1, 2, 3, 4. We have 4 of them, so we multiply by 4, and we get 2 square root 3 as the total area of this triangle, of this section. And now we have this, and now we have, let's change the color. And now we have this area, this area, and this area, and this area. And all those 4 are the same. So what we could do is I could kind of think about this as one section. So let's think about just this entire circle. And then if I cut it into this section, that is just 60 degrees of our arc. So technically it's not 4 times square root 3 over 2 because there's only 2 of the triangles now. So that means this area is just 2 times square root 3 over 2, which is just square root 3. And then from this arc is 60. So 60 out of 360 times our area of this, which is pi radius squared. So pi, so the radius is 2, so this is 4 pi. And then we need to subtract the radius, the area of this section, which is square root 3. And then we basically get this section, this area, and this area right here. And we need 4 of them, so we need to multiply by 4. Okay, So what does that simplify to? Well, this is 1/6. Cancel out the 2 here to make a 3. So this is 1/3. Cancel out the 2 here to make a 2. So that means this is 2/3 pi minus square root 3 times 4. So this area, so the area of those 4 sections is 8 uh, thirds pi minus 4 square root 3. Okay, so we know that is true. So that's the area of these 4 sections. And remember, the area of the 4 triangles is 2 square root 3. So then we could kind of add them together. So that would give us 8 thirds pi minus 2 square root 3 minus 4 square root 3. That is minus 2 square root 3. And that is our entire area of this small section. Now we just need to get our area of our triangle, which is pi radius squared, and our radius is 2. So that's 4 pi. So 4 pi minus this, and that is 12. So that 12 over 3 minus 8 over 3, that's 4 over 3 pi. And then minus a negative is positive, plus 2 squared root 3. And now we have to put it in the right form. So this is going to be 4 pi plus 6 square root 3 over 3. And then you can add up all the coefficients, and that will give us an answer of 16. Okay, so that is our answer for number 14. Now, number 15. The equation x cubed plus 3x squared minus 6x minus 12 equals 0 has solutions r, s, and t. The equation y to the power 3 plus ay squared plus by plus c has the solution 1 over r, 1 over s, and 1 over t. Determine a plus b plus c. Okay, so based on this equation, x cubed plus 3x squared minus 6x minus 12 equals 0. There's actually really special properties about this. Basically, if you take the negative of the sum of the roots, so r plus s plus t, that should be equal to your first coefficient, which is negative 3, which is equal to 3, basically. So, and now we can work on this one, which is negative 6. So then we have now the sum of the product of each of the two, so r and s plus r and t plus s and t. If you multiply them together, and that should be positive. So this should be positive, but so this is negative 6 because it's supposed to be positive, but it's negative. So this is negative 6 for a coefficient here. And then the final one is just r, s, and t, which should be negative. So that means this is just 12. So rewriting this because I want them all to be positive on one side. Let's just call this part negative 3. Okay, so we know that's true. And we're going to do the same thing for y cubed plus ay squared plus by plus c. So that means the sum of our roots, which is 1 over r plus 1 over s plus 1 over t, that should equal to our negative a. And our b is equal to 1 over rs plus 1 over rt plus 1 over st is equal to b. And now our c is equal to 1 over r, s, and t is equal to negative c. Okay, so we know. So now we just need to plug in values for this. Because if you simplify this on the denominator, this will just be rst as our least common multiple. So on the top here for r, this will be st, this will be rt, and this will be rs. So it'll just be the sum of the product of the two, which is negative 6, over our rst, which is 12. So that's negative 1/2. So that means a is 1/2. Okay, so we got that value. Now RST, that means the least common multiple is R, S, and T. So on this value, we have a T on top. On this value, we have an S on top, and the value of this would be R on top. So it's just be the sum of the roots, which is just negative 3, over our product, which is 12. And that is negative 1/4, which is equal to our B. So B is negative 1/4. Okay, now let's get the final value, which is 1 over RST, and RST is just 12. So we know C is equal to negative uh, 1 over 12. So we add them together, that's just 1/2 minus 1/4 minus 1/12. And this could just be 6/12 minus 3/12 over minus 1/12. So that's 4, 6 minus 4, that's 2 over 12, which is equal to 1 over 6. And that's our answer for 15. So you don't even need to solve for the roots. All we have to do is just kind of manipulate our variables around. And this is a really good idea for polynomials. Okay, now number 18. Let x to the power 5 minus k x to the 4th, w x to the 3 minus p x squared plus q x plus c equals 0, where k is positive, w is positive, p is negative, q is negative, and c is negative. Okay, determine the maximum number of positive roots for x in the given equation. This is actually a really easy question. You just need to know one theorem. It's called the Descartes theorem, or basically, or Descartes' rule of signs or something. I'm not exactly sure. It's one of these. Basic, or there's the same thing, I'm not sure, but it's basically something like that. And basically it tells us is that if there's a sign change between each alternating like um, term of a polynomial, then there is a possible positive root. So what we have is we have x to the power 5, and then minus x minus k. K is positive, so this is actually negative minus k, x to the power 4. And I'll say this k is positive. And then we have plus wx3 minus px squared plus qx plus c. And we have w, which is positive, p is negative, q is negative, and c is negative. That's equal to 0. So we just need to look for changes. So this is positive. So positive, negative, and positive. So this is overall negative. I mean, this is overall positive for this term. Overall for this term, this is negative. Overall this term, this is positive. Overall for this term, this is also positive. This term is negative, and this term is negative. So positive, negative, that's one sign change. So there's a possible root here. Negative to positive, that's another sign change. That's 1 here. Positive, positive, that's nothing, so there's nothing there. Positive, negative, there's 1 here. And negative, negative, that's nothing. So we have 1, 2, and 3. So the maximum possible positive roots is 3. And that's basically it. That's basically Descartes' rules of sign, or Descartes' theorem. I think I'm pronouncing his name wrong, but basically that's how you do it. Well, thanks for watching, and I'll see you at the next math record.